Okay, in this set of notes, we are going to look at projectile motion, but this time fired at an angle. So we're going to pretend that this is the ground, and this is like a golf ball. And so we have a golfer hits a golf ball at an angle of 40 degrees. So we're going to make this theta be 40 degrees with the horizontal, with like the x-axis. If the ball leaves the club with an initial velocity of 48 meters per second, so I'm going to write here the initial velocity is 48 meters per second. Calculate the time that the ball is in the air. The range means how far over it goes, and the maximum height reached by the ball. So kind of the secret to projectile motion problems is that we have this parabola going on, but we have to, instead of looking at the parabola, we have to break things down to what is happening in the x direction and what is happening in the y direction. So I'm going to take this little, I'll call it triangle over here. And so we're just going to like cut out a little piece of this triangle, and we're going to blow it up over here. So when I blow it up over here, this is the golf ball taking off. And so the golf ball is taking off with a velocity of 48 meters per second. And this is a 40-degree angle. So I'm going to close up that triangle over here. So that means that when the golf ball is hit, part of this hitting of the golf ball is going to project the golf ball in the x direction. And part of hitting the golf ball at an angle is actually going to project it upward in the y direction. But I'm going to write that over here. So the first thing that I have to do is take the initial velocity and break it down into its x and its y components. So let's look at the Vx. So that is adjacent to the 40. So I'm going to say cosine of 40 would be Vx over the hypotenuse. So that's 48. And just like when we did component method type of problems, Vx will always turn out to be the vector. Whoops, I did that wrong. 48, the vector 48 times cosine of the angle, cosine of 40. And so I'm going to write that right down here. Vx is going to be 48 times cosine of 40. And I am going to number crunch that. Okay, find the calculator here. Okay, so we have 48 times cosine of 40, and that is 36.77. So I have 36.77 meters per second happening in the x direction. Let's figure out what's happening in the upward y direction. So we'll call this Vy over here. So you can see that Vy is opposite the 40. So I'm going to write down sine of 40 will be Vy over the hypotenuse, which is 48. And I'm going to write that over here. So Vy equals 48 times sine of 40. So 48 times sine of 40. And I'm going to quickly number crunch that. 48 times sine of 40. And I get 30.85. 30.85 meters per second. All right, so let me say that again. Somebody takes out a golf club and hits the ball 48 meters per second. We will no longer use that 48, because what we have just learned is of that 48 meters per second, we have a velocity going in the x direction of 36.77, and the x direction is constant velocity. It is never going to change. And in the y direction, the ball is going to take off straight upward with a velocity of 30.85. So we are not going to use the 48 meters per second again. So I always kind of cross it out. All right, so the other day we were looking at projectile motion fired horizontally off a cliff like this. And we learned that the time to come down was the same as the time it took to drop straight down. Well, kind of like the reverse is true, that I don't know how long it takes to parabola up to the top, but it's going to be equal to the time if I had just like hit the ball straight up into the air. So I'm going to kind of dot this so it goes up to the same height as this. So we're going to talk to ourselves over here in the y direction. So the ball is going to take off with an initial velocity in the y direction of 30.85. So I have VI, and I could put a little y there if I want. And then as it goes up, it's going to get slowed down by gravity. So I'm going to write down A equals negative 9.8. And when it gets to the tippy top, the final velocity in the y direction would be equal to 0. And I would like to know how long it takes to go up. And I'd also like to know how high up it goes, but we'll do the height here in a minute. All right, so let's look at this, what we have going on, and let's look at that down here, the time the ball is in the air. So I'm going to use, based on the variables that I have, a VF, a TA, and a VI, I'm going to write down the first acceleration equation. So I'm going to write down VF equals VI plus AT. So a mistake that people make is when they see this VI, they like want to plug in the 48. But when you cross it off, that's a reminder we are not using the 48. We are using the initial velocity in the upward direction. So I'm going to put little Y's on here. So I remind myself it's the initial velocity in the Y direction. All right, so at the tippy top, this is going to be 0. The initial velocity in the Y direction is 30.85. The acceleration is negative 9.8, and I want to find t. So let's take this negative 9.8 t and bring it to the other side. Then it will become positive. And then I get 30.85. All right, so let's divide both sides by 9.8. So divided by 9.8. And I get 3.15 seconds to go up. All right, let's look at that for a minute. So that was the time to go straight up, 3.15 seconds. That equals the time to parabola up. So I'm going to write down on this half of the parabola, 3.15 seconds. Well, this is a symmetrical picture. So if it takes 3.15 seconds to go up, it's going to take 3.15 seconds to go down. So if the question is, how long is the ball in the air? I'm going to multiply by 2. And that's going to be 6.30 seconds. That's how long the golf ball is going to be in the air. All right, the next question is the maximum height. So I want to know how high up it goes. So I'm going to say D equals question mark. Well, this is in the vertical direction. And this over here is in the vertical direction. So I'm just going to put D equals question mark in my story. So I notice that I have a VI Y and a VF Y in my story. So I'm going to use acceleration equation number 3. So I'm going to say VF squared equals VI squared plus 2AD. But I'm going to put little y's here because this is happening in the Y direction. So at the top, that's a 0. And the initial velocity in the Y direction is not 48. It is 30.85. So 30.85 squared plus 2 negative 9.8 times D. So I'm going to move the 30.85 to the other side. And then I'm going to divide by 2 and divide by 9.8. And let's see what we get. So I'll do my algebra and you can do your own algebra. So divided by 2, divided by 9.8. and I get 48.56. 48.56 meters. That's how high up it goes. All right, so the next question is the range, how far over it goes. So how far over it goes is called dx. Like how far over does it go in the x direction? So we talked the other day that parabolic motion is the result of having an acceleration vector and a constant velocity vector. So this is again constant velocity in the x direction. So I'm going to write down here the constant velocity equation. So velocity is distance over time. But I'm talking about it in the x direction. So I'll put little x's on there. And so what is the velocity in the x direction? We found that right here, 36.77. So I'm going to write that in. So 36.77. And I'm looking for dx. And then t is how long is the golf ball in the air, like how long while it's going over. So that's the double time. And so that's going to be 6.3 seconds. Dx equals. So let's multiply that. And I get 231.65. 231.65 meters. All right. So when you have something fired at an angle, let's go through it real quick. You plot out the initial velocity that the ball is hit and the angle, but you immediately take that velocity and break it down into its x and its y components. You can write the x component down, you can write the y component down. And the three questions that we're always asked is, how long is the object in the air? How high up does it go? And how far over does it travel? When you're talking about how long is it in the air, it's going up into the air and it's going down. So we want to make sure that we are using the y component of the velocity. If you're talking about how far over, you have to remember that it's constant velocity and you're going to use the x component of the velocity. All right, so this is your sample problem for how to handle projectile motion fired at an angle.